Hello and welcome back to our AWS Certified Solution Architect Associate Certification Bootcamp. In this module, we'll tackle a crucial security topic for your certification exam, Amazon S3 encryption. Securing your data is a top priority for any cloud architect. We will cover the why and how part of encryption for your data stored in Amazon S3. In this module, we'll review different options you have for encryption. We'll start with Amazon S3 server-side encryption techniques, server-side encryption with S3 managed keys, which is called SSE-S3, server-side encryption with KMS managed key, server-side encryption with customer-provided key. Then we'll switch gear and we'll cover S3 client-side encryption, followed by S3 in-transit encryption or encryption in transit. Before completing the video, we will review S3 encryption best practices. On behalf of the Cloud Expert Solutions team, I would like to thank you for joining us and exploring this video. Let's get started. We will start with a very simple example. Let's assume we have our client and the customer is trying to communicate with the server. Maybe she is trying to send some data to the server. When the client is sending data via network, first encryption in transit to encrypt any data which is covering the public network or public internet. Then when the data reaches to server, we have to make sure the data is stored encrypted at rest, which is called encryption at rest. And for encryption at rest, either you can encrypt the data at server side or you can encrypt the data at the client side and send the encrypted data over internet to server. Using this analogy, let's understand S3 encryption. We'll use the same diagram, but we'll replace our server with Amazon S3 bucket. If you are uploading data or retrieving data from Amazon S3, either you can use client-side encryption, that means you can encrypt the data at the client side. While sending the data, you can use in-transit encryption. At the server side also, you can perform that encryption. While performing the server-side encryption, you have different options to manage the keys. And you can use either S3 managed key or you can use KMS managed key, or you can manage your key and send that key. And the very recent offering is dual layer server-side encryption with KMS. Now let's review these concepts one by one. We will start with server-side encryption with S3 managed key. This is the default encryption method for all new buckets and objects that are uploaded to S3. S3 automatically encrypt each object with a unique key at no additional cost and no performance impact on your application. The unique encryption key is further protected by a master key that Amazon S3 regularly rotates. Now the encryption key is handled and managed by Amazon S3. Amazon S3 uses 256-bit Advanced Encryption Standard or AES 256 encryption technique. Now let's understand using a diagram. We have our application user and the application user is trying to upload object into S3 bucket. There are multiple ways to upload the object. Either you can use AWS Management Console or you can use AWS SDK, AWS CLI or S3 APIs. If you are using default encryption and if you are uploading using AWS Management Console, then you don't need to specify anything additional. Just go to AWS Management Console and either you can upload a single file, multiple files or even a folder with many files. However, if you are using S3 API to create object, then you must perform either a put operation or a post operation. If you are using S3 put API, then you must specify a particular header which is called XAMZ server-side encryption and the value of the header should be AES 256. If you are using post operation, then you have to pass the same header, however it should be passed as a form field. Once your object reaches to S3, S3 will use its managed key and it will create the encrypted object. Then the encrypted object will be uploaded to Amazon S3. Now in terms of exam tip, if the question is saying the key is managed by S3, then it is hinting towards SSE-S3 or server-side encryption with S3 managed key. Next, we are going to cover server-side encryption with KMS managed key. This is not the default encryption. Either you can select this option at the time of creating the bucket, or if you have an existing bucket, then you can edit the encryption setting and you can enable this encryption option. This option will allow you to integrate with AWS KMS for managing the encryption key, and either you can use AWS managed customer master key, or even you can create and manage your own customer managed CMK. If you are using your own CMK, then you will have more control over the key lifecycle and the access policy. If you are using S3 REST API to upload the object, then you must add these headers. Please remember, you have to use XAMZ server-side encryption and the value should be AWS KMS. In addition to that, you have to pass a new header named XAMZ server-side encryption AWS KMS Key ID, where you have to pass the KMS CMK or KMS master key ID. Under SSE-KMS option, AWS KMS and Amazon S3 bucket performs an envelope encryption, and let's understand the entire process using a diagram. We will start with the upload process first, or the encryption process flow. When the user is uploading an object, first Amazon S3 bucket will request a plain text data key and an encrypted copy of the data key. That means it is asking the same key in two different formats, one in the plain text format and the other one in the encrypted format. Then AWS KMS will generate a data key, then it will encrypt the data key with the KMS CMK and sends both the plain text data key and the encrypted data key to Amazon S3. Once S3 bucket receives the data key, Amazon S3 will encrypt the data or the file using the data key in plain text format, and then it will remove the plain text key from the memory as soon as the encryption process completed. As a final step, Amazon S3 will store the encrypted object and the encrypted data key as a metadata with the encrypted file. Now let's review the decryption process flow as well. That means when you are requesting an encrypted object from Amazon S3, Amazon S3 will send the encrypted data key to AWS KMS in a decrypt request. Then AWS KMS will decrypt the encrypted data key by using the same KMS key it used previously, and then it will return the plain text data key to Amazon S3. Then Amazon S3 will use the plain text data key to decrypt the encrypted file. Then it will remove the plain text data key from the memory, and after that it is going to return the unencrypted object to the user. For the AWS certification, please watch for terminologies like managed by KMS, audit or key rotation. If you have encountered any one of these terminologies, that means it is hinting towards SSE-KMS. Now with SSE-KMS, you have two different options. Either you can choose KMS managed key, or you can bring your own key and upload the key material to AWS KMS and you can use that key. Now let's compare different S3 encryption at rest options side by side. And we are going to compare in respect to manage key policies, AWS CloudTrail logging capability, key rotation, data shareability, and default behavior. We'll start with SSE-S3. For SSE-S3, you do not manage the key policy. It is entirely managed by S3. You will not have any CloudTrail logging. The key rotation will be rotated by Amazon S3. You do not have any control. However, you will be able to share the data, and this is the default behavior. Moving to SSE-KMS with AWS Managed Customer Master Key or CMK. If the key is managed by AWS or KMS, you won't be able to manage the key policy. However, you will have CloudTrail login. The key will be rotated and regulated by AWS KMS. You won't be able to share the data unless and until the user have access to that particular KMS key, and this is not a default behavior. The last option, SSE-KMS with customer CMK. If you own that key or the key material, in that case you can manage the key policy. Since you are using a KMS managed key, that is why it will have the CloudTrail login in terms of who is using that key, when it is used. You will be able to manage the key rotation, you will be able to share the data, and it is not the default behavior. Now let's review the third category of server-side encryption. However, here you are managing the key outside the AWS region. Because you manage the encryption key on the client side, that is why you need to manage the additional safeguards like key rotation, key management, key security at your side. And in this process, you must use HTTPS. While you are sending the data, you must provide the encryption key at the HTTP header. And while sending the data and the key, you must follow some specific headers. To start with, you have to specify XAMZ server-side encryption customer algorithm. This is the name of the attribute and the value should be AES256. The attribute XAMZ server-side encryption customer key, where you have to provide the 256-bit base 64 encoded encryption key that you want to use for this encryption. And third, XAMZ server-side encryption customer key MD5. You also need to provide the base 64 encoded MD5 digest of the encryption key, and this will be used for integrity checking. Now let's understand the process with an example. Let's assume our customer is using server-side encryption with customer provided key. Then he or she has to provide the key with the uploaded object. Once the key and the uploaded object will reach into S3, S3 will use that key to encrypt that object. Then the encrypted object will be persisted into Amazon S3 bucket, and it is going to delete that key as soon as the encryption process completed. So in this process, Amazon S3 does not store the encryption key that you provide for the encryption. Instead, S3 will store a randomly salted hash-based message authentication code or HMAC value of the encryption key to validate future requests. This is a very important terminology for the AWS certification, and you have to remember that HMAC salted terminology. You also need to remember, if you lose that encryption key, any GET request of that object without that encryption key will be failed and you will lose access to that object. If you lose that key, there is no way you can create that key from that salted hash. This is another one important phrase for the certification. If you are thinking what could be the use case, because of regulatory and the compliance reason, if you need to maintain full control and procession of your encryption key outside the AWS region, then only you should use server-side encryption with customer provided keys. During the AWS certification, you should look for words like customer provided key or key sent with request. These are the two vital terminologies that AWS uses to hint you towards server-side encryption with customer provided key. When you are going to retrieve the object, you have to always pass that encryption key. Because of that fact, services like Athena and all, they won't be able to read the data if you are using server-side encryption with customer provided key. Now let's review client-side encryption. In client-side encryption, you need to manage the key outside the AWS environment, and in this process, you need to encrypt the data before sending the data to Amazon S3. That means you need to choose the client library or the encryption method, and you can also use Amazon S3 encryption client, because Amazon S3 encryption client can also help you to encrypt the object at the client side. Unlike server-side encryption with customer managed key, since you are already sending the encrypted object, that is why HTTPS or TLS is not strictly mandatory. Now let's understand the process using a diagram. As a customer, you have to encrypt the object with your own key and you need to create that encrypted object. Then you send that encrypted object to Amazon S3. Now, once the object reaches Amazon S3, Amazon S3 nowadays comes with default SSE-S3. Amazon S3 will use SSE-S3, that means S3 manage key, and it will encrypt the encrypted object one more time. So you are going to have two layers of encryption, and S3 will apply the SSE-S3 on top of your encrypted data. This is by default. If you want to use the data, then you need to decrypt that object at your client side with the same key you have used to encrypt. That is why in this process you need additional computational power, because you are managing and maintaining the encryption and decryption process at your end. And in terms of S3's role for this entire process, S3 will simply store the encrypted object and the metadata, and it will not participate in the main encryption or decryption process. S3 will only perform the default encryption, and it will add one more layer of encryption on top of your encrypted object. Now, in terms of exam tip, you should look for scenarios where client controls the entire encryption process. If you find any phrases like this is hinting towards client-side encryption, not for a server-side encryption. Now, because of regulatory reason, sometimes your organization requires two layers of encryption. That means you start with an encryption process at the client side, then S3 will again perform SSE-S3. To eliminate that entire thing, AWS recently launches dual layer server side encryption with KMS Key. This is a relatively new offering and it is not yet available for the AWS certification. However, this topic can appear any day in AWS certification exam. That is why it's good to understand this process as well. Dual layer server side encryption with AWS KMS or DSSE-KMS, it refers to two independent layers of AES-256 encryption. The first layer, your data is encrypted using an unique data encryption key which will be generated by KMS, and the second layer, the already encrypted data will be again encrypted using AES-256 encryption, and the key will be managed by Amazon S3. So now in this process, you have a combination of SSE-KMS and SSE-S3. To use this encryption technique, again you have to use some special header in your HTTP request if you are using API, and for this you have to use XAMZ server-side encryption as AWS KMS DSSE. This is distinctly different from AWS KMS, and also you need to use XAMZ server-side encryption AWS KMS Key ID, where you have to pass your KMS Key ID. DSSE-KMS provides enhanced protection against potential encryption vulnerabilities, and this particular technique will help you to meet regulatory requirements that mandates multiple layers of encryption. Since we are using two different layers of encryption, that is why this process has slightly higher latency, and you can understand the reason of that latency because of the additional encryption processing. And since we are processing additional encryption, here the charges will also be higher compared to conventional server-side encryptions. Now let's understand Amazon S3 encryption in transit. Normally when you are talking about in-flight encryption or in-transit encryption, the first thing comes to our mind the HTTPS endpoint and the TLS or SSL certificate for the SSL handshake. What does it mean to Amazon S3? How do you configure it? Where will you upload the TLS certificate? We are going to discuss everything in this slide. With Amazon S3, you don't have to manage and maintain any HTTPS endpoint or any TLS certificate, because Amazon S3 endpoints comes with two different versions, one HTTP endpoint and the same endpoint with HTTPS configuration. AWS always recommends you to use HTTPS endpoint. Now let's go back to AWS Management Console and let's review the process. Back to my Amazon S3 dashboard. This is the S3 bucket that we have created as part of our previous demo. I'll select this S3 bucket. This is the object we have uploaded as part of our previous demo. I am going to select that object And now I am going to copy the S3 URL. I have copied that URL and then opened a new browser tab and paste it here. Here you can see HTTPS. That means HTTPS, this is the default endpoint. When you are trying to access the object using that URL, we are seeing the access denied error. This is absolutely perfect because this bucket is private and the object is also private. We do not have a permission to access the object like that way. That is why it is coming like that. However, you can remove that HTTPS and you can use the same URL with HTTP. Again, you can see this is not secure, but the result is same. Back to my PPT. Although you have both the endpoint options, AWS recommends you to use the HTTPS endpoint. In our previous slide, we have reviewed that if you are using SSE-C or server-side encryption with customer managed key, in that case HTTPS is mandatory. And to follow best practices, you can also enforce HTTPS endpoint via a S3 bucket policy. In this policy, it is saying the effect is deny. That means we are going to deny any object. If the secure transport is false, that means if the request is coming in HTTP mode, then we are going to deny. If you add this into your S3 bucket, then you can make sure any HTTP request to your S3 bucket will be denied. Now let's understand using a simple diagram. Let's assume we have our customer. If the customer is trying to upload an object over HTTPS URL, then that upload request will be accepted. However, if the user is trying to upload an object using HTTP endpoint, then that particular request will be rejected and user won't be able to upload the object. And if you require the data you are uploading to Amazon S3 must be encrypted using Amazon S3 managed key, then you can use this bucket policy, and using this bucket policy, it will deny permission to upload object if that object does not follow or if that request does not have a header of XAMZ server-side encryption AES-256. We have already reviewed this, that if you are using API and if you are using server-side encryption with S3 managed key, then you must pass this header in the API request. This bucket policy will enforce that every upload request should come with this particular header and any other header will be automatically rejected. Before completing the video, let's understand some S3 encryption best practices. First, you should understand the sensitivity of your data and accordingly you should choose the appropriate encryption method. Then you should implement robust access control and regularly rotate your encryption key. And finally, you should monitor and audit S3 encryption configurations. It will ensure compliance and it will also detect any anomalies that may appear to your system. That wraps up this module. If you found this video helpful, please give it a thumbs up and subscribe for more AWS exam preparation courses and cloud certification bootcamps. Got questions or feedback? Drop them in the comment. We'd love to hear from you. Thanks for learning with us at Cloud Expert Solutions. You are now one step closer to crushing your exam. See you in the next module.